Hello dear students, welcome to the video lecture series on Western blotting, Unit 4 Immunoblotting Techniques under the syllabus designed by Pharmacy Council of India, third year B Pharmacy, 6th semester, subject Pharmaceutical Biotechnology, subject code is BP605T. Myself, Dr. J.P. Lavande, Associate Professor, Department of Pharmaceutics, Shulingeshwar College of Pharmacy, Almala, Taluka Ausa, District Latur. Dear students, already we have started the details associated with Western blotting, in which we had covered the principal and the SDS stage, that is the sodium dodecyl sulfate polyacrylamide gel electrophoresis. In this particular video, we will going to deal with the Western blotting and its detection, particularly the transfer, blocking, primary antibody incubation, secondary antibody incubation and analysis are the 5 stages. Among these 5 stages, in this particular video, we will go through the transfer blocking, and the next coming video, we will go through the primary antibody incubation, secondary antibody incubation and analysis. 5 steps involved in Western blotting and detection assay, namely transfer, blocking, primary antibody incubation, secondary antibody incubation and analysis. Proteins are moved from within the gel onto a membrane made of nitrocellulose. Hereafter it will be called as NC or polyvinylene difluoride, that is the PVDF. Without pre-activation, proteins combine with nitrocellulose membrane based on hydrophobic interaction, thereby having slight effect on protein activities. Besides, nitrocellulose membrane produces little non-specific staining. It is cheap and easy to use. However, it is easy to erase small molecular proteins while washing. It is fragile and has poor toughness. With high affinity, the PVDF membrane needs to be sunk in methanol before use to activate positive charge group on the membrane, promoting combination with negative charge proteins. Nitrocellulose membranes of 0.45 micrometer and of 0.2 micrometer are used most. The size of 0.45 micrometer should be applied for proteins with molecular weight over 20 kilodalton, while the size of 0.2 micrometer will be chosen for those below 20 kilodalton. PVDF membrane is best for the detection of small molecular weight proteins due to its higher sensitivity, resolution as well as affinity than normal membrane. Transfer methods that are used most for proteins are semi-dry transfer and wet transfer. Semi-dry transfer describes the method that gel membrane filter sandwich is placed between filters loaded with transfer buffer. The transfer process is based on current conduction produced by the transfer buffer. Semi-dry transfer takes little time with high efficacy as electric current works directly on membrane and gel. While applying wet transfer, the gel membrane filter sandwich is placed in the transfer and suspended in transfer buffer vertically. Proteins transfer from the gel to the membrane under the control of high intensity electric field produced by electrode plate parallel to the sandwich. While prolonging time to an appropriate extent, proteins could be transferred more effectively. Proteins within several gels could be transferred. Blocking. In a Western blot, it is important to block the unreacted sites on the membrane to reduce the amount of non-specific binding of proteins during subsequent steps in the assay using inert proteins or non-ionic detergent. Protein buffers should block all unreacted sites, and blocking buffers should not replace target protein on the membrane, not bind epitope on the target protein, and not cross-react with antibody or detection reagents. The most typical blockers are the BSA, non-fat dry milk, casein, gelatin, and Twin 20. TBS and PBS are the most commonly used buffers. Inertia protein BSA, non-fat dry milk, casein, gelatin or non-ionic detergent twin 20 reduce non-specific binding by blocking unreacted sites. Retaining protein structure twin 20 can reduce breakup to original interaction among proteins while is used for protein emulsification. Non-fat dry milk is the most economic choice. Avoid using non-fat dry milk as a blocking reagent for blots with biotin conjugated antibody because milk contains variable amounts of glycoprotein and biotin. BSA, bovenserine albumin, is appropriate for blots with phosphorylated protein as target. Phosphatase contained in non-fat dry milk leads to dephosphorylation of phosphorylated protein on the membrane, while phosphorylation-specific antibody is used to identify phosphorylated protein. And non-fat dry milk is improper for blots which rely on alkaline phosphatase system. Avoid adding NAN3 into blocking reagent for blots that base on HRP system because NAN3 is enabled to inactivate HRP. Casein is recommended for blots with alkaline phosphatase conjugated secondary antibody. TBS buffer instead of PBS buffer should be chosen because PBS interferes alkaline phosphatase. So dear students, thank you for watching. If you like this video, please hit the like button, share our videos to your friends and subscribe to our YouTube channel Dr. JPL Video Lectures by pressing the red color subscribe button to get notification about more such videos. Thank you.